Namaste. Today I am going to talk about the elementary signals, basic signals. These signals are also called basic signals. These are also called the benchmark functions or benchmark signals. Signals that are basic signals, and there are some complex signals also in practical life, but the complex signals can be expressed with the help of basic signals or elementary signals or benchmark signals. Okay, let us continue with what are different kind of basic signals available to us. So the basic signal in life that we see that was till now. Earlier, the scientists or engineers were used to measure everything with the help of trigonometry, and there was sine theta and cos theta was in picture. They were happy with sine theta and cos theta. It was a very wonderful signal, moving slowly, moving up, slowly moving down, slowly going down, slowly going down, like that. But as we have developed with the new processors, digital processors and all, then what was the need that why this signal, the first one, this became famous? Impulse. Usually people do not say that impulse is good. Impulse is not a good thing. Impulses are very hazardous. Impulses, because of the spikes in the signal, there is a lot of extra additional power consumption in the circuits. That spikes are impulses only. So, can anybody tell that what are the reason why this impulse becomes so famous in signal processing? For getting answer to this, we will be coming to the point. We will discuss what are the advantages of impulse signal later on. But the thing here is that impulse is what? Impulse is something very momentarily and with very, very high value coming out. That is impulse. Okay, so by the signal processing point of view, impulse is good. I will cover it in the later slide. Second is unit step signal. So it is like step, means like steps, stairs, steps in the stairs. So therefore it is called step signal. Ramp signal. Instead of stairs, sometimes there are ramps. In railway station, there are two ways to go to the overbridge. One is using the steps, and another is using the ramp. So then another one is ramp signal. Third one is parabolic. Parabolas you have seen like this. So this is a parabolic signal. Rectangular signal is representing a rectangle. Triangular signal represents a triangle, represented by a triangle. Signum is one, is a special form of the step, like signum. Sine theta, sine signal you already know. Cosine signal also you know, like this. Sync is a special one, like this, starts from a high value at 0 and goes down reducing with time. Gaussian signal is a binomial distribution kind of function. Exponentially increasing function, or exponentially decreasing signal. So, and complex exponential is the combination of exponential and sine and cosine term. Combination of exponential with the sine and cosine becomes complex exponential signal. Very good. Let us go further and discuss these signals one by one. First one is unit impulse signal. Unit impulse is very difficult to define. because the value of unit impulse at 0 is very difficult to find out. So therefore that is instead of value it is defined by the area. So I say that the signal which have area equal to 1 is called impulse signal. So area is calculated by the integration under the integration of the curve. So integration of a signal of delta t dt, the area of the signal is 1. Therefore integration of delta dt is equal to 1, and where t is not 0, then there at those all places delta a t is 0. That means except 0, I am not telling the value at 0 at this time. I will tell you later on that what is the value of unit impulse at 0, but I am saying that around 0 there is this one is in integration from minus infinity to infinity delta dt is 0. This is around 0, and delta t 0 except 0 means at 0 what is the value that you can see. You can watch see the Oppenheim book at section number 1.4.2, that this kind of analysis is given there. They have taken one signal, step signal. So this is a practical step signal, and ideal step, it will go directly to 1 without any time. In the instantaneously it becomes 1, but practically this doesn't happen. Practically this will go slowly and become 1. Okay, therefore here in this example I have taken this practical signal going to 1 in delta time. So 0 to delta, this delta time it is becoming 1. Okay, so this is one. This is also called step signal, steps u of delta t. So delta t, now I am taking integration of this. So when integration, already know integration of a of t, this is t, one kind of RAM becomes a constant. So and the what will be the slope of this? So y2 minus y1 upon x2 minus 1 upon delta will be the slope of this. Okay, so 1 upon delta will be slope of this. So this become the integration of this become a constant equal to the slope. Therefore it is coming 1 upon delta, and this constant value becomes 0. Integration of differentiation, I am taking differentiation of this slope is constant, and differentiation of this constant is 0. So this differentiation of this signal is like this. Okay, so I am coming to delta t by the differentiation of one step signal. Now this is like this, 0 to delta. So if delta tends to 0, and then this will become impulse signal. If this delta goes towards 0, then what will happen? It will increase, because we have to maintain the area of this rectangular shape equal to 1. Therefore this height will keep on increasing as we keep on reducing the delta, and when delta tends towards 0, this height of this impulse becomes infinity. So we say at t equal to 0, the value of impulse signal is infinity, but the area under the unit impulse function is equal to unity, and in representation of unit impulse signal, its area is representation. So when we represent it in the graph, then this one indicates that area, not the value. Keep in mind, in the continuous time impulse signal, the value at t equal to 0 is infinity, but the area around t equal to 0 is 1. Now I told that I will discuss the importance of impulse signal. So impulse signal, the first importance of this impulse signals is that they are very easy to generate. So they can be generated easily. and they can be applied to the system easily. It is very easy to generate impulse trains in the signal generators. And second one is impulse signal. By applying impulse signal to a system, we get impulse response. So when you apply impulse is applied to a system, then response is impulse response. If you apply any signal, then the response will be corresponding to that signal only. So then we get impulse response, and impulse response is actually transfer function of the system. So from impulse response actually represents transfer function of the system. So it is very easy to calculate transfer function of the system from impulse signal. Second one is the area under the impulse response, the curve, the area under the curve of the impulse response. If it is finite, then system is said to be stable. So stable system have finite area under the curve of impulse response. Okay, so stability can be easily find out from the impulse response. That is why impulse signals are very useful. And third one is the step is integration of impulse, and ramp is integration of step. Therefore, from impulse response we can get step response and ramp response. Means impulse response, if you have, just you have to integrate. If you integrate, then you can get step response, and if you integrate it again, then you can get ramp response. Okay, so this is the way to get the ramp response and the impulse response using impulse response. That is why it is very impulse signal. That is why it became very famous in the signal processing or digital signal processing algorithms. Okay, second signal is unit step signal. Unit step signal, as I told, that it is the step. Unit step means step of one size 1 is unit step. So for this you can say the value for unit step is for t greater than 0 it is 0, or for t less than 0 it is for t greater than 0 it is 1, for t less than 0 it is 0. Okay, but at t equal to 0 it is undefined. The value at t equal to 0 is undefined. It is not defined. Therefore, I have removed this equal to sign from here. Okay, for t greater than 0 it is 1, for t less than 0 it is 0. But as I told earlier, that many times we take the final value as the value of the function where it is undefined. So sometimes it is taken as 1 also. One practical examples, how can we generate a unit step signal. Here I have taken one battery source. It is connected to a resistance, and then it is connected to a switch, and then we are taking connecting here a voltmeter that is giving the reading of the voltage. Okay, so as I turn on the switch at t equal to 0, the switch is turned on. Then after the switch is turned on, we can see the voltmeter reading equal to Vs. So for t 0 to infinity, the value of output voltage will be equal to Vs. But before turning on this circuit from this switch, the output voltage was 0. So for minus infinity to 0, the voltage will be 0. So this can be written as minus infinity to 0 it is 0, and from 0 to infinity it is Vs. So this is like this, 0 to Vs. This is a unit step signal. This is a step signal, not unit. If this Vs is equal to 1, then it will become unit step signal. Okay, but it is a practical way of generating unit step. Unit ramp signal. Unit ramp signal. Unit ramp signal is actually a signal which increases continuously with respect to time. It looks like a ramp in the railway stations. Over bridge, if you want to go, nowadays there are three ways to go over the railway bridge. So if you have a railway bridge here, suppose it is a rail bridge, how can reach to uh, this place? One way is left. One way is left is connected here, so this left goes up directly to this point. So by way left you can reach to the bridge. Another way is to go to the left by step signal. So by steps you can reach to the bridge, like this, like this, like this, like this, you can reach here. So another way is step. And third way to reach this point is, you can for the handicapped people and for other people, is a ramp. Ramp is slowly moving up. You can move it, wheelchairs over it, other things. So this is a similar ramp one. Ramp is here. So this ramp signal. A ramp signal is represented by T. Its slope is 1 for 0 to 1, and for t greater than 0 it is T, and for t less than 0 it is 0. At 0 its value is 0. So RT, actually this can be written as T times UT. Okay, or you can write RT is the integration of ut minus infinite to plus infinite. So RT can be obtained by the integration of the unit step signal. Okay, ramp signal is can be obtained by applying the unit step to integrator. Okay, so minus infinite to t ut dt, minus infinite to 0 it will be 0, and for 0 to t it will be t, so we can get t. So ut is the and also the unit step is the differentiation of the ramp signal. So the reverse is also true. Ramp is the integration of unit steps. In this way, this is the just introduction of ramp signal. Parabolic signal is again integration of the ramp signal. So when you integrate a ramp signal, then it becomes a parabolic signal. Function is the name given to the signals only. So when you integrate t, it will become t square by 2. Therefore, I have taken here t square by 2. Okay, for t greater than 0, it is t square by 2. For t less than 0, it is 0. So this t square by 2 is actually y is equal to x square kind of parabola. Therefore, it is opened towards y axis. Okay, and here it is equal to t square by 2 ut, and it is the ramp signal is differentiation of this parabolic signal. Next signal is unit rectangular signal. See, rectangular pulse is like this. This is a rectangle. So rectangular shape pulse width of tau. So if I start it from minus tau by 2 to tau by 2, then it is a rectangular signal. If it is centered at t equal to 0, and if its amplitude is 1, then it is unit rectangular signal. Okay, so minus tau by 2 to tau by 2, and mod t means minus tau by 2 to tau by 2, it is 1 and 0 otherwise, then it is a rect pi of t by 2, or this, or rect t by tau, and this should be actually tau, not t. This is a tau because we are taking its interval as tau, minus tau by 2 to tau. So here we represent its interval tau, minus tau by 2 to tau. Okay, or this is also called rect t by tau is equal to 1 for mod t minus pi by 2 to minus tau by 2 to tau by 2, and 0 otherwise. So this rect t or box car or box t by tau, or this is also called a box car function, box car signal. also called gate signal. Gate signal is rectangular signal only. Okay, so and as you see that this is um, symmetric towards y axis, therefore it is even signal. It is even function or even signal. Next one is triangular signal. So similar to rectangular, triangular is also centered around 0. It goes like this, both side, and tau is the time interval. So it starts from minus tau by 2 and goes towards the tau by 2. Its amplitude is also 1, and this is 1 minus 2 t by tau. Actually, this is the function 1 minus 2 t by tau for this minus t to t. So you can say that here it will become 1 plus 2t by tau. Here it will become 1 minus 2t by tau. Okay, and 0 for less than tau by 2. And minus tau by 2, and for greater than minus plus tau by 2, it will become 0. Okay, so this is a triangular signal. This is also even similar to the previous rectangular signal. And signum looks like something special, but it's not too much special. It is very simple. Signum means unit step and reflection of unit step with respect to origin at a signum. It is a signum function. Its value is 1 for t greater than 0. Its value is minus 1 for t less than 0. It is an odd signal. You can see that it is having the mirror image around origin, therefore it is an odd signal. And mathematically we can write SGN instead of signum completely. Many times it is written only as SGN. Okay, so also we can represent with the help of UT. You can see that if I have U of t, now it can be converted, it is UT. If I multiply this by 2, so this will become 2 UT, and if I take a minus 1, so minus 1 plus 2 UT will result in this signal only. Okay, so signum t is equal to minus 1 plus 2 UT. Is it okay? It is important and useful also many times in the analysis. Next one is sinusoidal signals. These were very popular from the ancient time. And sinusoidal is which starts from 0, goes up and then goes down, then goes up like this. So xt equal to sine t. Many times you see not in a sine t, and this is a sinusoidal signal. And cosine signal, it starts from 1 at 0, goes down and goes up like this. Next, this is a cosine signal. Then next one is sync. Sync is signal that have maximum value at origin and oscillates both sides with respect to. And this is a derivative of sine signal only. It is derived from a sine signal only, and it is a decaying sine signal. We can say with respect to time. This sine t divided by t means it is dividing. It is reducing with dependency of time. So you can see that this t is dependent on time. So this sine t is dividing by t means sine t is decaying by some time, decaying with respect to time. So this is important, that it is uh, it have time period of 2 pi. The sync signal have time period of 2 pi, and it decays continuously with the time. So it is decaying with increase in time, and mathematically we can say since t equal to sine t by t for minus infinite to plus infinite. Okay, the value of this sync function is 0 at the multiples of n pi. So when you go from this point like this, it is touching to at n pi, means pi, 2 pi, 3 pi, 4 pi. It is touching zeros at n pi, and n equal to 1, 2, 3, 4, plus and minus also. So it at minus pi also it touch like this, minus pi, minus 2 pi, like this. So you can see that this is also even function of time. So sync function is uh, is even function of time. And so as I told that this is, what is this, what is this, what is this, you have to say this is minus pi, minus 2 pi, minus 3 pi, and so on. Similarly, pi, 2 pi, 3 pi, 4 pi, 5 pi, and so on. It will continue. The value is 1 maximum at 0, and it is then continuously it reduces with respect to time. Okay, next one is Gaussian signal. This is a part of binomial distribution. It is very useful in probability analysis, and probability is related to signal for the noise analysis. There is Gaussian noise in communication system. Many times Gaussian noise comes in the channel, so the analysis of noise is done with the help of this Gaussian signal. Okay, so this is represented by e to the power minus a t square, e to the power minus a t square for minus infinity to infinity, and for minus 1.52 plus 1.5 it goes maximum 1, and then again it reduces. It never touches the x-axis. Next one is exponential signal. Exponential means exponentially increasing or exponentially decreasing. Okay, so a function that represents either increasing or decreasing series. A continuous time signal, exponential signal, is defined as e to the power et alpha t, e to the power alpha t. So the value of alpha, if this value is positive, if this alpha is positive, then it is increasing. So if alpha is positive, then this is increasing. If alpha is negative, then this is decreasing. Okay, so exponential signal can be increasing or decreasing, either increasing or decreasing. So if alpha is greater than 0, it is growing or increasing. If alpha is less than 0, then it is decaying or decreasing. When alpha is 0, the third case, then it is a constant signal. So that is not exponential signal. So all e to the power alpha t, for all values it is not exponential signal. Okay, so this is not exponential signal. This is exponential, this is exponential. Okay, so this e to the power alpha t for alpha greater than 0 or alpha or I can say alpha not equal to 0 is the exponential signal, f exponential signal, f of t equal to the power for alpha not equal to 0 is exponential signal. Okay, next one is discrete time real exponential signal. So for discrete exponential it can be written as alpha a to the power n. That is also exponentially increasing sequence. So if a value of a is less than 1, then there is growth. If the value of a is 0 to 1, between 0 to 1, then there is decay. Sorry, this is wrong. If alpha is less than 0, then it takes alternating sign. So it is, if it is greater than 1, then it is growing signal. For alpha greater than 1, the sequence is increasing or growing. For alpha 0 to 1, a equal to 0 to 1, it is decreasing or decaying. For alpha less than 0, it is alternating. Increasing or decaying, or what happened, or in alternating, but alternatively. Okay, next one is complex exponential signal. If signal is complex, means here instead of alpha t it will be st. So a e to the power st, where s is a complex variable, s equal to sigma plus j omega. Okay, so this is called complex exponential signal. So sigma plus j omega can be written as e to the power sigma t plus e to the power j omega t, and e to the power j omega t is cos omega t plus j sin omega t. So I can say that this e to the power alpha t is now multiplied with sinusoids. So there are three possibilities of e to the power alpha t like this, and when it is multiplied with the sinusoidal, then it will be a constant sinusoidal. If it is a is s equal to 0, and then if s is equal to sigma only, then it will be increasing values. So if sigma is less than 0, then it will be decreasing. If sigma is having greater than values, then it will be increasing. Depends on the value of sigma. Okay, thank you all. Thank you so much for your attention. I'm ending here. Be happy.